Hi guys, here we're going to do some notes on standard deviation. And basically standard deviation is one of the most widely used ways to measure the spread of a sample. And what standard deviation does is it compares every single point of the data to the mean, okay, which actually is important because it actually uses every single point of the data set in its calculation. So people like it a lot more than just like interquartile range and some of those other measures that sort of measure spread of data. Okay, and so you can read a little subnotes here, but I'm going to go ahead and move on and work out an example for you. So this first example here is dealing with ungrouped data, so just raw data that hasn't been put into a table or no frequency has been taken or anything like that, just raw data. All right, so I'm going to take the data from here, this 2, 5, 4, 6, 7, 5, 6 here. I'm going to put that in my table. So I've got a 2, a 4, 5, 5, 6, 6, and a 7, okay? And that total is going to be 35. Okay, so that last column, I'll just sort of make it a total column. So now if I want to find that x bar, because in order to do x minus x bar, I have to know what x bar is. So the mean, or x bar, is all those numbers added together, the 2, 5, 4, 6, 7, 5, 6 added together. We said that was 35, divided by the total number of points in the data, which is 7. So the mean here ends up being 5. All right? So then x minus x bar, I'm taking every one of those numbers and I'm subtracting 5 from it. So 2 minus 5 is negative 3. 4 minus 5 is negative 1. And then we'll get 0, 0, 1, 1, 2. All right? And then if I square all of those numbers, we're going to get 9, 1, 0, 0, 1, 1, and 4. Okay? And the total of this column right here ends up being, so if I had 9 plus 1 plus 1 plus 1 plus 4, that ends up giving me 16. So that's my total there. And so to find the standard deviation, we use this little formula. So standard deviation is equal to the square root of the sum of the x minus x bar squareds. So that's this last column here, the 16, divided by the number of data points, which is 7 in this case. And so that's roughly 1.512. So what does that mean for us? A standard deviation, approximately 2/3 of all your data is going to fall within one standard deviation of the mean, okay, if your data is roughly bell curved. So I'll write that out for you. So roughly 2/3 of the data falls between 5, that's the mean, plus the standard deviation, 1.512, and 5 minus 1.512, okay, which if you actually figure those out, it's going to be 3.488 to 6.512. So according to this data, 2/3 of the data will fall between that 3.488 and the 6.512. Okay. I used a little s to represent standard deviation. Another abbreviation you'll see for standard deviation is a lowercase sigma. Looks kind of like that. So you're going to see a smaller s or a sigma to represent standard deviation depending on, depending on the particular example. They're kind of interchangeable. All right, so that's ungrouped data, just raw numbers. If I have a bunch of numbers and I make a little frequency table with them, like the first two columns here, so you'll see like a value for x and then a frequency for x. So how many, there's 11 3s, there's 4 12s, there's 5 13s, so on and so forth, okay? The formula changes slightly in the fact that right here, you'll see that we take the frequency, the sum of the frequency, and multiply it by the x minus x bar squared. Okay? So I'll show you that. In order to find x bar for this example, though, in order to find the mean, we have to go ahead and multiply the frequency by the score and get that sum, and then we'll go ahead and divide it by the total, because x bar, or mean, is the sum of f times x divided by the total number. So 11 times 3, that's 33. Then we've got 48. Okay, then we've got 65. 28, 120, 144, 85, 144, 114. Okay, and since I'm eventually going to need the total of that column, I'm just going to go ahead and add those up real quick. That ends up being 781. Then if I look at my frequency column, if I add the entire frequency column up, I get 50. So my mean is going to be 781 divided by 50, which is about 15.62. All right. And so then I've got my mean, so now I can do x minus the mean. So the first one's going to be 33 minus, nope, it's going to be 11 minus, because it's x, so 11 minus the mean, which is 15.62. So 11 minus 15.62 is negative 4.62. And I'm going to quickly go through the rest of them. You should see the pattern and be able to go through this pretty quick too. It switches here when we go positive. All right, and then I'm going to square all those numbers. I actually should be taking these out to about 4 decimal places, but in the essence of time, I'm only taking it out to 2. Okay, and then I'm going to multiply each of those columns by the frequency for this last column here. So 21.34 times 3. I'll fill out the rest of the column real quick. Okay, and then I'm going to go ahead and find the sum of that column, because I'm going to need that here. So the sum of that entire column is 283.78 approximately. Okay, and then I just use that formula from up above, this formula right here. So I'm going to take that sum and I'm going to divide it by the total frequency and square root it. So I'm going to go down here. And so standard deviation is square root of that sum of our last column, which was 283.78, divided by the total number from this data set, which was 50. Okay. And so when I actually calculate that, it's going to be roughly 2.38. So 2/3 of our data is roughly 2.38 units from that 15.62. Okay, on to the next slide. Okay, so for this next data set, we have grouped continuous data. So now there's going to be intervals, okay? And just like in our stats packet, when there's intervals, we're going to operate from the midpoint of those intervals. So this first midpoint is 4.5, then 14.5, and so on and so forth. You'll see the pattern. Okay, and then we've got our frequency column already there, and so I can jump into the f times x so that I can get that data so I can figure out what the mean is going to be. So f frequency times each midpoint value, so 4.5, 14.5, 49.0, okay, so on and so forth. Okay, and then if I total that whole column up, I should get 4,780. Okay, so my mean calculation, my x bar, that is just going to be that column, the 4,780 divided by 80, and that should be just under 60, 59.75. Okay, so now I've got x bar, and so I can go ahead and do this x minus x bar column. So x, so 4.5 minus 59.75 is negative 55.25, and negative 45.25, and again, you should see the pattern, so go ahead and just fill it out. And we go positive again, so it's going to be 4.75, 14.75, okay, and then the next column we're going to square those numbers. Okay, and then we're going to multiply each of those numbers by the frequency for that last column. So the 3052.6 times 1, okay, 3052.6, and then so on and so forth, so fill out the rest. Okay, and then I find the total of that column, so 22,594.99 basically. Okay, and same formula here. We go ahead and, so to find the standard deviation, we set it equal to that last column, 22,594.99 divided by 80, so it's roughly 16.8 for that standard deviation. Okay, so now you've seen an example of ungrouped data, grouped data, and then this continuous with intervals group data. So you've seen kind of three main examples here, standard deviation. The only other thing I wanted to show you real quick was how to compare the spread of a data. So if you have different types of data with different sizes, different averages, different means, you can still compare the data using this coefficient of variation. And all that is you can read all the stuff that goes with it here, but the formula is this right here. The coefficient of variation is equal to the standard deviation divided by the mean times 100. Okay, so for example 1 here, we're going to compare the variation of two stores to see which one has the greater dispersion or greater variability, okay, amongst these two stores. So in store A, the standard deviation is 50, the mean was 500, and we're going to multiply that by 100, which gives us 10%. For store B, the standard deviation was 68, the mean was 800, and we're going to multiply that by 100. That gives us 8.5%. So even though store B had a greater standard deviation, the coefficient of variation is actually less for that data because it had a higher mean also. Okay, so that means store A actually has the greater relative dispersion, even though it has a smaller absolute dispersion. Okay? And so that's it for our notes today.